So this is assessment video 9A, and the problem starts off with this equation here, the conservation of energy equation. And the problem starts off with a company uses a compressed spring to shoot a 2.5 kilogram box up a 1 meter high ramp into a truck. So this is right here is the 1 meter high ramp, and this 2.5 kilogram box is being pushed up it. And there's this little area here called the sticky spot, and it's 50 centimeters long. And the spring has a K equal to 500 newtons per meter, and it's compressed to 0.36 meters. And for question A, it asks us, at what speed do the boxes enter the bed of the truck? And to solve for this, we use this equation, the kinetic energy, the initial kinetic energy equals 1/2 mv, the initial times the initial velocity squared. So this is because since the initial velocity is 0, so the kinetic energy is also, the initial kinetic energy is also 0. And for the potential energy, the initial potential energy, we also use the equation 1/2 k times I squared equals, so we just plug in what we have from what we're given. So we plug in our k value, which is 500, and then we plug in the I value, which is 0.36. And this is when the spring is compressed, so it's going to be 0.36 squared, and then from this we get 32.4 joules. So also there's no external force, so the external work done is equal to 0. And if we take the final kinetic energy, for the final kinetic energy, we just use basically the same equation, which is 1/2 mvf squared. And for the final potential energy, we use mgh, which is so we just plug in 2.5 times 9.8 times the height of the bed of the truck right here, the height of the ramp, which is 1 meter. And then for this here, we get 24.525 joules. And for the delta, for the change in the thermal energy, there is no change. So this equals 0 because there is no friction. And then the question goes back to this equation here. So to get our answer, the conservation of energy equation. And up here we got our Ki that we solved for, the potential, the initial potential energy, the external workforce done, Kf, Uf, and then the change in the thermal energy. So the question asks, at what speed do the boxes enter the bed of the truck? And then we just plugged in what we have from up here using this equation, and we just get the VF, which equals 2.509, and that's going to be the answer for part A, for what speed we need the box to enter the truck. So yeah, we just plug in for that. And for part B of the question, it now asks us, so some sand is spilled on the ground in front of the ramp, causing friction, and the kinetic coefficient equals 0.4 on 0.5 meters of the ground. Do the boxes still make it to the bed of the truck? So we want to know, do the boxes still make it to the bed of the truck? So we're given, so the kinetic energy equals 0, the initial potential energy equals 32.4, and the external work done is 0. And we use the equation kf, and we get 1/2 mvf squared. And then here we also have the final potential energy, and this equals to 24.525, and that's what we solved for in the last problem. And then we got the delta, the change in the thermal energy, and this is work done by friction, and it's going to be the potential energy minus times newtons times d times d, and here we have this here that so N equals mg, mass times gravity, acceleration due to gravity, so we do 2.5 times 9.81. So our N is going to be 24.525, and then the potential energy is 0.4. That's the, oh, actually that's the kinetic coefficient. And then for D, it's 0.5 meters off the ground. And we just plug it into this equation here for the change in the thermal energy. And from that we get 4.905. And this brings us back to using the this equation here, the conservation of energy equation, and we take the initial kinetic energy, the initial potential energy, the external work done, force done, WF or KF, UF, delta, the change in the thermal energy, and we just plug all that we have up here that we solved for and was given. And from this here we get 2.375, and then we just solve. So you take the square root of that, and then we get the VF, which equals 1.5414. And since it's 1.5414, the box will still make it to the bed of the truck. And that's our answer. Oh, and I also didn't explain the diagram, so this is what's going on here, which is the newtons, mass times the gravity of the block, and then the UN value. And yeah, that's how you solve for this for part B, and it will make it to the bed of the truck. And this relates to what we're learning in class, because in class we've done we're learning right now a lot about how the conservation of energy works, and applying its the equation to various problems such as this. So that's kind of how it relates to what we're learning. We'd want to know how fast something is going to make it up like a ramp. So yeah, this is kind of just how it relates to what we've been doing.